Welcome, wonderful people. This is Mr. Ndabezita once again, and we are looking at N2 engineering mathematics. So this is question paper number 16030192. It was written on the 31st of July 2023. It's an X paper. 3 hours were provided in order to complete this test. So let's just get right into this. Right, what we have in here is the following. Let me just put this a little bit like this. Very good. So we have the following. Let me just draw up a line. They say to us in here, question 1, solve for P and R in the following simultaneous equation. We have minus 12R plus 8P, it's equals to 32, twice R plus 3P equals minus 14. So solve for P and R simultaneously. So now with N1 simultaneous, they would normally give you the coefficient of R or P where the value is 1. So in these ones you can see there is no possibility of such. So what we need to do, we can say this is equation 1. It doesn't really matter which one you say, it's 1 or 2. Then from 1 we make either P or R the subject of the formula. So I'm going to say 8P equals 32 plus 12R, and I'm going to divide by 8 so that P it's equals to 32 divided by 8 plus 12 divided by 8R. And let's see if there's any possibility of simplifying some of the terms there. Let me just try and check. 32 divided by 8, that would give us 4, and 12 divided by 8, that would give us 3/2. So we have this is 4 and this is 3/2R, because you will be dividing both numerator and denominator by 4 in order. And even here, maybe how many 8 can you pull out of 32? 4 of them. Right, that is fine. And then from here, this would be the value of P. Now because we made P the subject of the formula, we would say this is equation 3. And then we are going to substitute 3 into 2 being the equation that we have not yet worked with. So in equation 2, where we see P, we will be writing this. So twice R plus 3, I see P, I will write 4 plus 3.5 R, and I'm going to equate this to minus 14. Be that as it may, I can say twice R plus 12 plus 9/2R minus 14, removing the brackets by multiplication. And then from there, these are like terms, therefore I can find the answer. 2 plus 9 divided by 2. 2 plus 9 divided by 2 it's 13 divided by 2. 13 divided by 2r, it's equals, I will have minus 14 minus 12. Minus 14 minus 12. That we should give us minus 26. Right. I want to get rid of the denominator. I can multiply both by 2. 13r 26, 12 minus 52. I can divide by 13. How many 13s can I pull out of 52? 52 divided by 13. I will get an answer of 4. Minus 4. And this would be equation 4. And then I'm going to substitute 4 in 3, where p is equal to 4 plus 3 divided by 2 into minus 4. This would be 4 minus, this would give me 12 over 2, which is 6, and the answer is minus 2. Very good, because this time this is 12. 12 divided by 2 is 6. 4 minus 6 minus 2. Let's try and check if it is true that when I substitute r and p, I will get 32. So all I'm going to do is to say minus 12. The value of r is minus 4 plus 8. The value of p is minus 2. So this should give me a value of 32, and exactly that is what I get. So I am very correct in what I have done. But if there's somebody with a memo, you would just go and check for us. But we have proved at least that we are correct. So let's go to 1.2. In 1.2 they say solve the following quadratic equation by using the factorization method. 4e squared 27e 45 is equals to 0. Solve the following quadratic equation using the factorization method. So we need to factorize this. Right, I know that the quadratic formula says minus b, so that would be minus 27 plus the square root of minus 27 squared is the same as 27 squared minus 4 into a, which is 4, into c, which is 45, divided by 2 into a, which is 4. And you would get a value of minus 3. So meaning we have 4e and e, this is positive 3. And let me just go and substitute a positive with a negative. And I find negative 15. Very good. So e equals minus 15 over 4, or e equals minus 3. So I have solved for e using factorization method. Right. Now in 1.3 they say Make C the subject of the formula. We have 5 divided by 7C3 equals W minus T divided by C3. We want to make C the subject of the formula. Okay, let's regroup the C's. Right, this is what we would get, and then from here, it's truly our choice what we want to do. I can multiply everything by 7C3. So if I multiply by 7C3, let me show you here. This is how we do it. Plus T. This is equals to W. I'm multiplying everything by 7C3. This into this goes once. This into this goes once. You are left with T times 7, which is 7T. And then here 7C3W. Right, remember I want to be left with C, 7W, 7W. And then 7 and W goes once, you are left with C3. So C3, it's equal 5 plus 7T all over 7W. And then I can introduce the third root here, so that I have the third root of 5 plus 7T all over 7W equals C. This is what I would get. 5 plus 7T divided by 7W. So this is exactly what we would get. Right, that is fine. Let's go to 1.4, which marks the end of question 1. A father of 5 boys intends to travel out of town for the weekend, but before traveling he gave his eldest son a sum of 2755 to share with his brothers, such that the 5 amounts should form consecutive whole numbers. Now we need to look at the wording here and some buzzwords. A father of 5 boys, that's a total number of boys, intends to travel out of town for the weekend, but before traveling he gave his eldest son a sum of 2755 to share with his brothers, such that the 5 amounts should form consecutive whole numbers. Calculate how much each son would receive. Now let the first son be represented with the alphabet X. It's a whole number, so let me just show you this. Consecutive whole numbers: X plus 0, X plus 1, X plus 2, X plus 3, and X plus 4. 1, 2, 3, 4, 5. So these are consecutive whole numbers because they start with 0 with increment of 1. And this sum is equals to 2755. X plus 1 plus X plus 2 plus X plus 3 plus X plus 4. This should be 2755. X plus X plus X plus X plus X, 1, 2, 3, 4, 5. This would give you 3, 6, 10. X equals 2755 minus 10 divided by 5. And let's see what value of X we would come up with. Right, we have 2755 minus 10 divided by 5. It's 549. What did the question say? calculate how much each son would receive. Alright, so the first x is this, let's say x1. The second one will be x plus 1. This is 550. You add 1. 551. You add 1. 552. You add 1. 553. The sum of all this should give us 2755. Let's check. 9 plus 0 plus 1 plus 2 plus 3. This would be 10. This would be 15. 5 carry 1. This would be 5, 10, 15, 20, 24 plus 1, it's 25. 5 carry 2 because it's 25. And then lastly 5, 10, 15, 20, 25 plus 2, 27. So we are correct. So this would be the share of each. And that brings us to the end of question 1. Right, let's try to go to question 2. Now in question 2 we have the following. They say that we should simplify in 2.2.1 y plus 3 x squared minus 4x plus 4 plus xy minus 2y plus 3x minus 6. Right, let's try to simplify this. Now there's nothing I can do in this one. I can factorize this. The factors of 4 that can give me 4, it's 2 and 2. The bigger number takes the sign of the middle term. Unfortunately, there's no one which is bigger. But I know that when I multiply this, I'll get that. When I add this, I'll get this. There's something common in here, which is y. And I'll be left with x minus 2. There's something common in here, which is 3. And I'll be left with this. Can you see this? So this is 3x minus 6. Very good. And then from here, what is it that I can do? I still have my y plus 3 x minus 2. You can say square it there. There's something common in here, which is x minus 2. You'll be left with y plus 3. Very good. And then from here, what is it that I can do? What is it that I can do? I can take out an LCD because that's exactly what I see there. So my LCD would be x minus 2 squared y plus 3. Very good. You'll always take the one with the highest exponent. This into this goes once, this times that. That's y plus 3 squared plus this into this goes once, this into this goes once, leaving another one. That 1 times 1, it's x minus 2. Right, that being fine, what is it that I can do? I can remove the brackets there, and I will get y squared plus 6y plus 9. Please, when you remove the brackets there, I have plus x minus 2. I have x minus 2 squared y plus 3. Are there any like terms that I can group on top? Yes. Y squared plus 6y plus x. What is 9 minus 2? It's 7. All be divided by x minus 2 squared y plus 3. I think I can just leave it here. Right, that was 2.2.1. Let's go to 2.2.2. In 2.2.2, I think there's something that I can do. Remember, I'm simplifying. I'm given 5x plus 6b divided by x minus 7. This has to be divided by 25x squared minus 36b squared divided by x squared minus 49. Anything common in there? No. Right, I can immediately change division to multiplication here. They will swap. This is a difference of two squares. And there's something common here, because 25 is this is also a difference of two squares. 25 is 5x, 36 is 6, and 6 b minus plus. That's what a difference of two squares is. And then from here, look what is happening. And you are left with x plus 7 into 5x minus 6b. And it's just 3 marks for that, so nothing much had to be done. Nothing much truly had to be done. Okay, that is fine. Let's continue in this. Let's go to 2.3. They say factorize 20x squared minus 45 over 81. 3 marks are provided for this. Factorize completely. Now, what is it that I can do here? The first thing that I should ask myself, right, 20, let me write this as a product of its prime factors and see what we would get. 20 equals shift and fact, it's 2 squared times 5. So I'm having 2 squared times 5x squared minus, let's look for 45. 3 squared times 5. Let's look for 81. 3 to exponent 4. Now, I want you to see something here. Right, I'm going to simplify first this, because it can be simplified. So 2 squared times 5x squared minus, I have 2 of these. When I cancel 2, I'm left with 2 on the denominator. So this is 5 over 3 squared. Something worthy of noting. And then from there, what is it that I can do? Right, what I can do from here is the following. I can say I'm factorizing. There's something common this side, which is also common on that side, which is 5. So I'm going to say 5, and I'm going to say 4 x squared minus, and this is going to be, if I want to get that 5 on top there, I'm going to say 1 over 3 squared. Can you see this? This times this would give you that, and this times this would give you exactly that, because it would be 5 divided by 3 squared. Right, and then from there I can factorize this, because it's now a difference of 2 squares. 4 is the same as 2x and 2x. This is 1 over 3, 1 over 3, because when I multiply, I will be adding the exponents there. Something worthy of noting. So that would be the factorization of that. It just needs you to think a little bit, not much, but just a little bit. Let's go to question 3 now. Solve for t in 3.1. Solve for t if log subscript 2 t the third root of t equals 2 divided by 3, 2/3. Right, solve for t. Now if I were to solve for t here, can you see this? That I can change this from logarithmic to exponential. I can have 2 to the exponent of this being equals to that, which is equals to t the third root of t. I can have this. Right, solve for t. Now from here I can simplify this. So I can have t, write what is inside of the square root, remove the square root. If there's a 3 there, you will always say 1/3. Right, from here there's a 1 there, use the laws of exponents to simplify. So you would say t, and you would say 1 minus 1/3. So let's just find that. 1 minus 1/3. It's 2/3. This is exactly what we get. Now from here, remember I'm looking for the value of t. I can multiply both these exponents by the reciprocal of 2/3, which is 3.5, 3.5. This into this would go once. The value of t would be 2 to the exponent of 1. Very, very important. So t equals 2. This is some of the simplest algebra of all time. Now let's go to 3.2.1. Now in 3.2.1 they say simplify each of the following without using a calculator. Log subscript 32 times log 4 2. So I have log 16, log of subscript 16 to 32 there. So what can I do with this? Now I'm having log of subscript 16. Now 32, let's go and look at 32. Now 32 equals shift fact, that is 2 to the exponent of 5 times, and I want you to check here, you have log 4 like this. So what we can do here is to use the change of base theorem. So meaning we can say, let me show you something, because I believe the formulas are provided here, but let's see whether what we want will also be provided, and they did not provide that. So meaning they assume that you understand what is happening. So in that case, in this case, even if we can take 5 to the other side, it's going to be problematic. Why? Because there's no way we can cancel here. We need to use the change of base theorem. Now let me do this. Let me say, if you go to the calculator and you say log subscript 16 base 32, it will give you an answer of 5 divided by 4. I want to show you this. Log this would give you 5 divided by 4. Now how was that obtained? That is the question. How was that obtained? Right. Now remember what we said here. We said 32 is the same as this. So meaning what we do there, this is this. Now meaning we are saying log, let's check, is it true that we are saying log 32 divided by log 16? Are we doing this? Let's check. This would be log 2 5 all over log 2 4. Take this to the front, you would get 5 log 2 all over 4 log 2. Are you with me? Now look, this into this goes once, you have 5 divided by 4. Can you see that? So now let's try to redo this. We have log 1632 times log 4 2. Are we fine? Now we're going to say, we're going to use the change of base theorem. We're going to say log 32 log 16 log 2 log 4. I know this is the same as log 2 5. This is log 2 4. This is still log 2 and log 2 2. Are we fine? Take to the front 5 log 2 4 log 2 log 2 2 log 2. Are we fine, wonderful people? This into this would go once, 5 divided by 4. This into this would go once, but you are left with a 1, remember, over 2. 5 times 1 is 5. This times this is 8. Let's see if this would give exactly that. So I'm going to say log 16 and I'm going to say 32, and I'm going to multiply this with log subscript 4 base 2, and the answer boils down to 5 divided by 8. So we are very correct in what we have anticipated here. Right, be that as it may, let's go to 3.2.2. Log of subscript this 1 over 8 minus this 1 over 32 minus this 1 over 4. So we can work on this. We know that when we divide numbers of the same basis, we can just, but it's entirely your choice. Somebody would decide to go the long route with this, and we are still fine with that. Somebody might want to say 1 over 2, 3, changing that 8. 32, we know it's 2 to 5. Somebody might want to take this route. We are not against anyone, never and ever against anyone. Somebody might want to rewrite this, taking this to the front. You see how somebody would prefer. This is somebody guys. Minus 3 plus 5 plus 2, because if you take this to the front, this is 1 times minus 3 is this. You take this to the front, negative by negative is positive, this is 1. Negative by negative is positive, this is 1. Somebody might want to do this, I indabes it. And then minus 3 plus 5, that is 2 plus 2, it's 4. This is somebody guys, somebody totally different. 3.3, use laws of exponents to simplify the following. This is grade 11, grade 10. It's amazing to find this in N2 engineering mathematics. Twice n. Right. We can rewrite this as 5, 3, which is being multiplied by n plus 1, 5 squared, twice n. And we can have this 3n plus 3, 4n. And somebody might say, when I multiply, I add. When I divide, I subtract. So somebody might say n plus 3n, it's 4n minus this is 0. 5 to the power 3, 125. This is somebody guys, somebody totally different. So this is what we would get. Right. And then we can pause here, and I will see you in question 4.